Okay, now that we've talked a little bit about main effects and interactions, let's see how these things play out in research designs. So imagine that I and someone else perform in a visual search experiment, and I perform in a task where I have a set size 6, and someone else performs the task when they have a set size 12. And my score is here, whatever this is, and someone else's score is there, whatever that is. So why do I have the score that I have? Why do they have the score that they have? Well, let's think about all of the things that could influence our scores. So each of these arrows represents something that's going to affect our scores. I only have a few of them up here, but you can imagine there would be lots and lots of things that are going to affect the response times to complete the task. So the search type, whether or not we're performing a conjunction search or a feature search, is going to affect our response times. So you can imagine that we're performing a conjunction search, and this is difficult even at set size 6. So that puts our search times up. For both of us, this is going to push both of our scores up. Imagine that I have set size 6, right? So I've got 6. So having 6 takes more time than having 1. So that pushes my score up a little bit. I am older than the typical college student, and typically as people age, after a certain point, their response time slow. So since I'm older than average, you can imagine that I'm going to be, on average, a bit slower than other people. However, I'm caffeinated. So because I've had some caffeine, this should help speed me up. I should be a little bit more alert. So that will decrease my response time. As a research participant, I'm fairly conscientious, and I'm motivated to do my best in research that I participate in, so that will also decrease my response time. But maybe I didn't get much sleep last night, so I'm tired. That will increase my response time. Maybe I'm a little bit distracted for some reason, even though I am motivated. That will increase my response time. And there could be lots and lots more, but what we have here is an indication of my total response time, which is determined by all of these things. So, the search type pushes me up, the set size pushes me up, my speed pushes me up, caffeine pushes me down, motivation pushes me down, tiredness pushes me up, distraction pushes me up, and all of these things contribute to my eventual score. The same thing is going to happen for another person. So that person, they're doing maybe the same search type, but they have a larger set size, so this should push them up. They might be faster or slower than me in general, so that will push them up or down compared to me. They may have been caffeinated or not, so all of these things can vary between myself and somebody else. So now the question might be, do we have, can we draw conclusions about an effect of set size? And at this point, hopefully you guys all say, no, we can't. Why not? Well, we only have one data point for me and one data point for someone else. So the search, or the set size, is confounded with my speed and my tiredness. And the set size 12 is confounded with their speed and their motivation and all of those things. So there's no way to really tease those things apart. I want to mention that there is one thing that's typically done in laboratory experiments that are like this. So I mentioned that the search tasks, the data that I showed response times between 400 and 800 milliseconds. So most people are able to perform a trial. A trial is just a single observation of a participant doing some task that you're interested in. So if we only have one trial, we don't necessarily have the best indication of how a person is performing, right? If a single trial, maybe I'm not used to the task yet. Maybe I haven't really gotten into the groove or anything. So in laboratory experiments, especially ones that take a small amount of time to complete a single trial, we use lots and lots and lots of trials. And instead of this point representing my performance on a single trial, that would actually represent a mean. Now, what is this going to buy us? Well, by giving me a lot of trials and by giving someone else a lot of trials, what should happen are things like temporary distractions. So you might imagine that sometimes I'm distracted a little, sometimes I'm distracted a lot, sometimes I'm not at all distracted, right? So on average, I'm going to have some amount of distraction. But on a single trial, I could be very distracted or not at all. So there's a lot of variability within the trials that have to do with my temporary distractions, maybe temporary motivations, and other things. So by taking a mean of a number of trials that have the same search type, the same set size, my speed on average, my motivation for that day, the level of tiredness I am, what that's going to do is minimize the variations in my scores and give you a much better estimate of how I would really perform given everything else. Now, so we can take a lot of observations of a single participant and create a mean and plot those. But typically we don't just look at one person, right? We look at a lot of people. And why do we do this? We look at a lot of people because even though I might be a little bit slower on average, some people are going to be a little faster on average. I might have a bit of caffeine, other people won't have any caffeine. Someone might have alcohol and that will slow them down. But by taking a lot of people, a lot of these differences should disappear. You think about how these all add up. If I'm really tired, but someone else is really alert, right, then those things are going to balance out. And by sampling a number of participants and then randomly assigning them, what we're doing is we're ensuring that things like my speed balance out with other people's speed, and that my level of caffeine balance out with other people's level of caffeine, and so on and so forth. So just as taking multiple samples decreases the variations in my score and will give you a better estimate of how I really perform in a particular condition, given my level of tiredness and everything, by taking a mean of a number of participants, we're getting a much better idea of how people in general perform for a given search type and a given set size. So hopefully that makes sense. Now, let's imagine that we have a visual search task, and we can have two ways that we conduct this experiment. We can either have a between subjects design, where we have one group of subjects always getting set size 6. So they do this a lot. Each participant might do hundreds of trials because it's quick and easy for them to do. So each person is going to be slightly different. Some will be above, some will be below, some might be right on. But on average, the group mean is here. And another group, right, this is a between subjects design. Another group always gets set size 12. And similarly, some people will be slower, some people will be faster, some people might be really close to the mean, but on average, we're going to have something like that. Now, contrast this with the within subjects design. So instead of having different groups of people participating in the different conditions, we have the same individuals participating in both conditions. Now, this is going to be really important. When we talked about t-tests, this is something that could be analyzed with the t-test. And if you think about it, what this allowed us to do, imagine, I'm going to use a different color, imagine that this is my score, because I'm a bit slower and whatever. This is my score for set size 6. I'm a member of Group A. I also participate at set size 12, and my score is up here for set size 12. Now, when we did a t-test, what I said that we were doing is basically getting rid of variability that's due to the individual subject. Let's see what I mean. If we take the Group A average at set size 6 and compare my score to it, I have this big of a difference, right? So whatever that is, let me plot this over here. So this is going to be a difference from the mean. Diff from mean. Boop, boop. Okay. So this is how much different I am from the mean at set size 6. Now for set size 12, we can do the same type of thing. Here I'm this much different from the mean. So what can we see in this situation? Well, in both situations, I am slower than average, right? So I am worse in both group A, or A on set size 6 and for set size 12. So this means that there's an effect of me. When we had the single situation where I just participated in one condition, sorry, I'm not sure you can see that, where I just participated in one condition, you really aren't able to get a sense of whether I'm just slower or faster or any of that compared to the effect of set size, because it's completely confounded, right? But here, I have two observations, and maybe these two observations represent means of dozens or hundreds of trials. So maybe they're really good estimates of how I perform in set size 6 and set size 12. So this suggests that there's an effect of me, effect of William. So think about the effect of me and what that means and how we can figure out what the effect of me is. Well, remember when we were talking about main effects, I said that you could collapse across the levels of the other variables. So if you collapse across the levels of the other variables and take the average, so if this is my score on 6 and this is my score on 12, then the middle point of that is here. So this is the effect of me. Effect of me. Here we are. That's a main effect of William. Woohoo! I'm slower. Great. And you can think that every potential participant is going to have some effect of them. Some will be faster, some will be slower, for a number of reasons. They might be more motivated, they might just be faster in general, they might be older, younger, whatever. But notice, when I drew this out, I'm going to get rid of these lines because they sort of complicate things a bit. So if overall this is the effect of me, notice that the effect of me really depends on the set size. So for the set size 6, I am a bit faster than I am in set size 12. And notice that this represents the difference between me and the mean. So it's really just an effect of me that differs across these various set sizes. So what does this mean? It's an interaction. It's the interaction between me and set size. Now, the great thing about repeated measures or within subjects designs is that we can basically figure out the effects of people and get rid of them. So, just like I did here, if this is the effect of me, right here, we can get rid of the effect of me and see how much I differ from the mean of me by getting rid, or by subtracting each of these data points from the mean. So here, actually I'm going to subtract the mean from the data points, right? Because when we were doing means, we were doing some observation minus the mean, so I'll stay with that too. So this minus that, so that is this big, so that's going to push me down here. Pardon me. Sorry about that. So this represents the difference between my score, or the difference between my difference in set size 6 from my average difference across both set sizes. And this is going to represent the other ones. So this is 6, this is 12. That's an effect of me, and this is the interaction between me and set size. So what does this interaction represent? Why do I differ between set sizes? Well, if we did a number of different trials, especially if I had some Imagine that I'm not doing all set size 6 trials and all set size 12 trials at different times. I'm doing them all mixed up. Randomly, I'm getting some set size 6 interspersed with set size 12. So you don't have to worry about like general things like, oh, I'm more practiced with one versus the other. So what these represent are basically errors. Why am I slower than in 6 and why am I faster in 6 and slower in 12? I don't know. It could be a number of things. Just like we did before when we looked at the things that can affect my response times, we can imagine that there are things that are going to be related not just to my speed and caffeine and motivation in the search type, but to the way that I interact with the different search types and different set sizes. So these interactions between me and set size, these are basically errors. We're not sure why I'm faster and why I'm slower. And when we are doing a between subjects interaction, you can think about we have some effect of group, right? That's this big. So that's our effect of group. We have some effect of me and some effect for each subject that participates. And we can basically get rid of those effects and look at the interactions between all of the subjects with the different set sizes. And we can use these interactions as our error. So if you remember, when we were talking about ANOVAs, I said that the statistic we're going to use is the F statistic, and this is basically a mean squares effect over mean squared error. When we have a between subjects design, we are going to have something like this. Our mean squares, I'm working with the set sizes again. So set size, this is the effect of set size, over what? The mean squares. What's our error? Well, if this is between subjects, we really can't determine if a subject is faster than average just because they are a faster than average subject, or if they have interacted with the set size in a particular way. So because we can't tell the difference between them, they're confounded, basically all of that is error. So these differences in the subjects are going to determine our error. However, for within subjects design, we have something different. So our F is going to be the mean squares for our set, right? The effective set that we're interested in. And the mean squares, well, we're not going to use just the subjects, right? Because we were able to take this out. So instead, this is going to represent the error. So this is the set size by, using an asterisk, by subject interaction. And we have basically gotten rid of the effect of subject to see whether or not there is an effect of set size. And this is going to give us more power, a greater ability to detect effects. Now, something that is really important has to do with variables that vary between subjects and variables that vary within subjects. For variables that vary between subjects, we're going to have a limited ability to determine whether or not the individual differences for subjects reflect differences in how fast they are, just in general, or whether they represent differences in how they responded to a particular level of that variable. However, for the within subjects designs, we're able to tease that bit apart. And this is going to be important when we talk about larger designs where we have more than a single variable.